learn. Today you try to
Okay, ma'am.
I'll read that. Okay, so
Okay.
today's topic is frames. Frames. Frame is like a construct. Frame is like a construct which will store the attribute value pairs for the nodes. Each node in a semantic net. Do you remember semantic net? We have
Yes, ma'am.
living thing, and then um, apple, and then John. Some examples we studied in which we had different concepts represented in the form of a node. So what you do in frames is you represent every node of semantic net in the form of a frame. So it is nothing but a data structure which are used to represent uh, attributes of a concept. For um, okay, example, the structure of a frame is like this. You will have a frame name followed by slot filler. This slot filler is like an attribute. The name of attribute in this context is a slot. Essentially, slot and attributes are same. So we have slot means attributes, and then we can have different default values for attribute, and we can have constraints on the values um, within the slots of a frame, and pointers to other frames, and you can have a subclass, you can have instantiation procedure, inheritance procedure, default inheritance inference procedure, triggers. All these make up a frame. So you to represent um, a hospital frame, for instance, look at here, hospital frame. If uh, you know, frame is similar to a object oriented programming concept of class, where you have number of attributes and operations, and then you create instances of class. Likewise, you create frames, and nodes are the instances of frames. Hospital frame has these slot names primarily, which are attribute names, and these are the values, and then values in the sense um, you provide any default value or value has to be accepted by the user, and these are the actual values. So you have frame name, means the name of the hospital, which is metro. Country, by default it is India. Phone number, default it is this number. Address, and address is this one. So this is an example of hospital frame. AKO, this is used to link two class frames. For instance, if you want to link a child hospital to a hospital, certainly you can do that type of tasks with AKO relation. And instance, it is representing a particular instance of a class frame. Uh, if you create a hospital frame, AIMS Hospital at Delhi or Usmania Hospital at Hyderabad can be the instances of that. Part of um, every hospital will have wards. So, ward is a part of a hospital. That these are different value pair concepts, and now we'll look at one complete example of a frame description. So we have hospital frame, which is the root of the network, which has these attributes or slots. Let us call them as slots along with their values. And this child hospital frame. Child hospital frame, if you observe here, you have the name, you have AKO, which denote the kind of relationship. So, child hospital is a kind of the main hospital. Maybe a hospital has its units, child unit, ladies unit, like that. So, heart hospital is also a type of hospital under the root hospital. Labs are also part of a hospital. Wards are part of hospital, and doctors are also part of hospitals. Pathology are also part of hospital. X-rays are also part of hospital. Orthopedic ward is a kind of hospital, like an instance. Hospitals will have different branches or different specialized units. So these may be among them. And this is the hospital frame instance, a particular hospital details and particular lab details, pathology, child hospital. This is the graphical representation of the frame network for the class hospital. So hospital is the root, AIMS is an instance of hospital, and all these child hospital, heart hospital, orthopedic hospital, um, okay, child and heart are the part of hospital, whereas orthopedic is a part of ward, not hospital. Okay, orthopedic ward is a specific type of ward, which is a part of a general ward. Then you have labs. In lab you have pathology, which is a type of lab, and X-ray lab is also a type of lab. And heart hospital escorts, maybe it is the name of heart hospital, which is an instance of that particular hospital. And essentially this Kalavati is a name of the child hospital, which is an instance of child hospital. So this is like a frame system. Do you understand this? Do you have any doubts? And this is three-dimensional representation of hospital. Three dimension, if you observe here, it is like a cube. So these are two dimensions, and this side it is a third dimension. You are representing this whole view in three dimensions. And you can also have inheritance in frame, and you can implement frames uh, in this manner using Prolog programming language, which is a language to represent the logic concepts. Okay, students, who are there in the class? Only Manisha is there. and two both the my both Manishas are there. So do you have any doubt in this topic? Going ahead, uh, we will begin with the next topic, which is an expert system. Can any one of you tell me what is an expert system? Yes, students, please respond. No. For example, if I say that that particular person uh, um, is pediatrician, or if I say that that particular person is a gastroenterologist or cardiologist or ophthalmologist. What are these? These are nothing but their specializations. They are the doctors. So instead of calling them a doctor, we call them a cardiologist because he is an expert or a specialized doctor of a particular field, which is heart. An expert system is also an specialized computer program, um, and expert system represent their knowledge and expertise as data and rules within a computer system. So if I say that a particular program is a expert system or for the diagnosis of uh, uh, different types of fevers. Okay, so what computer program does is it has got multitude of rules, and it has got knowledge, and it has got data. And then what does it do? We studied in our last chapter that um inference mechanism is used to uh, deduce deduce conclusions or derive new conclusions. So for that purpose, uh, you should have the knowledge represented in some form. It can be a propositional logic, it can be predicate logic, it can be semantic net, it can be extended semantic nets, or even it can be frames. So if you represent the knowledge in some form, and then a new question is posed to the system or our computer program, which is also known as an expert system, then it has to uh, derive the conclusion in the form of yes or no, or it can also give you the actual value. So it turns out that when a patient, uh, suppose a patient visits our expert system, which is a computer program, and specify his symptoms. If he say that I have uh, got fever, I have got uh, cold, I have got headache, I have got breathing problem, and then am I suffering with the flu? Or a patient can also say that what is the condition I'm presently in. So what the expert system has to do? Expert system has to look into the knowledge base that has been created for it, and then by applying various rules, modus ponens rule, and other forms of rules, introducing conjunction, eliminating conjunction, introducing disjunction, eliminating disjunction, all that by using different types of rules, finally it states whether the person or a patient uh, is indeed having a particular condition, and what condition is it. So example of expert system is mycin, mycin, mycin. This mycin uh, it was developed using the expertise of best diagnosticians. You know, diagnostician are nothing but one who diagnose what type of disease or a condition a person is suffering from. So, best diagnosticians of bacterial infections were asked, and the knowledge has been collected and then coded in the form of a computer program called mycin. And surprisingly, mycin performed better than an average clinician, an average doctor. The uh, number of positive cases that he has identified is less than the positive cases identified by mycin. So mycin, although it is a computer program, it has performed better than an average clinician. There is another real world case at a chemical refinery uh, wherein an expert system was uh, developed uh, by uh, leveraging the uh, experience of a retired employee uh, to save company from incurring the loss, and then that computer program is called as an expert system, which is which possesses um, the knowledge uh, of uh, a engineer, a chemical refinery engineer. Okay, students, I hope it is clear. The introduction to expert system. Let us look at the phases in building an expert system. How we can develop an expert system. There are 5 phases in which an expert system is developed. Identification phase, conceptualization phase, formalization phase, implementation phase, testing phase. So identification phase determines the important features of the problem um, with the help of a human domain expert. Essentially, a domain expert is the one who possesses and exhibits tremendous knowledge about a particular domain. For instance, a cardiologist is a domain expert of heart diseases. A neurologist is a domain expert of nerve diseases. Likewise, um, an engineer, civil engineer is a domain expert of construction. So it turns out that in the initial phase, uh, the human domain is a human of a particular domain, human expert of a particular domain is consulted to uh, to get all the important features of an expert system. Means a doctor is asked, how does he diagnose, how does he identify the disease, what medicine does he prescribe, and um, how he interact with a patient. So all these features are extracted from the expert. Then in the second phase, after you get all the features of a particular domain, you get to decide the concepts, the relations, and the control mechanisms to describe the problem solving method. What happens is, um, uh, a problem has to be solved eventually. What is the problem? The problem is a patient who is having a heart pain. Uh, Try to consult a domain expert who is a doctor. So now we are trying to make our computer program a doctor. How a doctor asks the question, diagnose the disease, and prescribe the medicine. Similarly, computer program should ask the questions, diagnose the disease, and prescribe the medicine. For that, in the initial phase of identification of features, we have um, gathered the knowledge or the features of that particular domain from the human expert. In the second phase, we decide on what are the concepts, what are the relations between them, and what is the control mechanism to describe this problem solving method. From the computer programmer perspective, you have to conceptualize the whole idea. And then formalization phase involves expressing key concepts and relations in some framework which has been supported by expert system building tools. You require tools to build a expert system. When you require tools to build an expert system, what happens is, um, you need to express key concepts and relations in a form which is supported by building tools of expert system. For instance, if you use a C programming language, you have to use functions, procedures to represent certain functionality. Whereas if you choose an object-oriented programming language to write the code for an expert system, uh, you need to uh, express these features and facts in the form of class and object. So what happens is, after you get the idea about what you are building, you need to represent or express, you need to express that whole idea in the form in the representation which is supported by the tools. It can be a programming language, it can be a database system, whatever tools you are using to create a expert system. Then implementation phase. In the implementation phase, what happens is, uh, the knowledge which has been formalized in the preceding phase is converted to a working computer program, which is also called as a prototype of the whole system. After you uh, first you try to gain the knowledge about the features, followed by the uh, decision about the concepts and relations. Going ahead, you choose the uh, tools and express whatever has been um gathered so far in the form of uh, in the syntax of a tool. And going further, you develop a program, a computer program, which uh, which exhibits the behavior of a expert. So you get a working model which is called as a prototype. And finally, the testing phase, you evaluate the performance of the prototype system. What happens is, this prototype system has to be tested because it is an expert system. You need to pose queries, and then it asks a related queries to you, and it come to a conclusion. It gives you its conclusion or whatever it infers, and finally it prescribes something. So for that, whether it is doing all this properly or not, you have to test it. Who has to test this? This testing has to be done by the domain expert. If you have created a computer program uh, to exhibit the behavior of a cardiologist, then a cardiologist only has to evaluate that computer program, which is called as an expert system. And the cardiologist will provide a feedback, and that feedback is used to revise the expert system if required. So, do you understand an expert system? Let us move ahead to the next topic, which is knowledge engineering. Knowledge engineering is quite significant topic in an expert system, because the whole process of building an expert system depends on how efficiently knowledge is engineered. What is knowledge? Knowledge is the information or the data which you are collecting from a human expert, and that uh, knowledge you um, formalize in the form of a computer program. And therefore, this knowledge collection, the process of knowledge collection, and then knowledge e- uh, it's sometimes you need to uh, go through all the facts and figures that are given, and if something is missing, you have to take care of that. And if something is out of scope, then you need to take take necessary action about that. Uh, all these tasks are referred to as knowledge engineering. Means you are creating knowledge. Engineering is nothing but developing, constructing, or creating something. When I say software engineering, you are creating a software program. When I say civil engineering, you are creating some sort of buildings, apartments, uh, malls, and various other kinds of buildings. And hence, here, knowledge engineering is about creating uh, a knowledge, a useful knowledge, which is efficient and which is correct and right. So, an specialized uh, worker or a person um, called as knowledge engineer performs the task of knowledge engineering. Knowledge engineering is done by knowledge engineer. So, what are the tasks of knowledge engineer? Knowledge engineer um, ensures that the computer has all the knowledge which is needed to solve a particular problem, and it has to choose one or more forms to represent the required knowledge, and it has to ensure that the computer can use the knowledge efficiently by selecting some of the reasoning methods. Uh, if you recall, we have studied at reasoning methods or um the methods like natural deduction system, axiomatic system, um semantic tabulae methods, resolution refutation, and inference mechanisms through inheritance in semantic nets and forward and backward chaining. Um, all that, all those methods are used for reasoning or deriving conclusions. So, a knowledge engineer has to efficiently select some of the reasoning methods which are better for that particular expert system. Okay, now this is the figure that shows the interaction between knowledge engineer and domain expert. Domain expert, for instance, if you are developing a uh, cardiology program, cardiology computer program, which is called as a card, an expert system in cardiology. If you are developing that, then the domain expert will be a cardiologist. Knowledge engineer is the one person who performs knowledge engineering, means um, getting the knowledge, refining the knowledge, enriching the knowledge, and formalizing the knowledge, and selecting reasoning method for the knowledge. What is the interaction between them? Do knowledge engineering asks questions or queries from the domain expert, and domain expert gives the answers or solutions. And the knowledge engineer take these strategies, take the answers, solutions, formulate strategies, rules, and create a domain expert system. Is this clear to you? The next concept is knowledge representation. Knowledge representation is Once knowledge engineer gets all the knowledge from the domain expert, what knowledge engineer has to do? Knowledge engineer has to represent the knowledge for a computer program. So how can a knowledge engineer represents the knowledge in a computer program? So it is mentioned here that the collection of domain knowledge is called as a knowledge base. Okay, the collection of domain knowledge. Domain knowledge means, again, for instance, cardiology, if you take all the information related to heart diseases, that is the domain knowledge which a knowledge engineer has extracted or asked a domain expert who is a cardiologist in this case. Whatever knowledge has been collected by a knowledge engineer uh, is known as knowledge base. And um, we require inference engine. Inference engine, or what does inference engine does? An inference engine uh, derives conclusions, okay, from the knowledge base. And then how do you represent the knowledge? We represent the knowledge in the form of rules. And these rules are said to be production rules. These production rules are in the form of if-then statements. So if person is suffering from this, then this. Else if person suffering from this, then this, and so on. So essentially, what is happening here is um, all entire knowledge has been uh, represented in the form of rules, which are production rules. So using production rules, what is done is uh, knowledge is represented. Another method for representing the knowledge is a frame or a semantic net. A frame is, if you remember, a frame is a data structure that encompasses the slots. Slots are attributes and their values for a particular node. So you can also represent knowledge in the form of a frame uh, or a semantic net. I hope it is clear how to represent knowledge. Going ahead, expert system architecture. This is an important question also. Uh, frequently asked question. Expert system knowledge architecture. This is an architecture of an expert system. So what does it comprises of? An expert system has inference engine. Can anyone tell me what is an inference engine? An inference engine is uh, the component or a unit of our expert system which is used for deriving conclusions, for deriving inferences. whenever a new query is given, an inference is derived or deduced. So this is an interface uh, um, that is a special interface with which the inference engine interact, and user will interact with expert system through user interface. Human expert is the domain expert. The domain expert interact with this unit or a component, and then what happens is, um, here you have a database, dynamic database, and this is static database. Static database is a fixed database. Dynamic database is a growing database which will incorporate the real world knowledge as and when a new knowledge is created, that is being added to the dynamic database. So you have two types of databases in your knowledge base. This entire thing is a knowledge base. A knowledge base is a collection of domain knowledge. Uh, so primarily what happens here is a user interacts through user interface, and this user query is stored in this dynamic database, which is our working memory. And then this explanation module interacts with the knowledge base and provides explanation to the user, like how a expert provide an explanation. For instance, if you um, if you go to a doctor and if you say that there is a burning sensation in my heart, then doctor uh, may first test you and then uh, explain you about that particular problem, and may tell you that this burning is due to acidity. You please avoid this fried food and junk food. So this is like an explanation which is given by uh, a human expert, which in case here is a doctor, a cardiologist. So explanation module will provide some sort of explanation to the user, and the entire knowledge has been gathered or acquired through this human expert and will be stored in this knowledge base. And you know what happens, the by this inference engine also uh, talk to this knowledge base, and there may be some case history. If a new patient comes, if a new case arrives, then it is solved, and then likewise you solve so many cases, then they become case histories. So this case history is used by inference engine and also by this human experts, uh, also uses this case history. And mm, so here the important components are all are important components of a system. The user interacts with the system through user interface, which may use menus, natural language, or any other style of interaction. An inference engine is used to reason with expert knowledge, uh, as well as the data specific to the problem being solved. So this case specific data is also used by this inference engine, and also the knowledge base is used. And case specific data includes both the data provided by the user and the partial conclusions along with certainty measures based on this data. So user also provides some data and some conclusions are derived, they may be partial, so that together is nothing but that case specific data, which is case history. And forward chaining rule based system, what happens in that particular method is case specific data will be included in the working memory. Okay, those are case specific data. Suppose this user's case specific data is included in this working memory. And then all expert system poses explanation subsystem to allow the expert system to explain its reasoning to the user. And some systems also have a knowledge acquisition module, which uh, will get the knowledge from the human expert. Okay, I hope these components are clear to you. Okay, students, I hope that today's class is useful to you all. You all have understood today's class. Please go through it once. You know, now only if you open the uh, soft copy of the textbook and read it, then it will be really uh, very useful and it leaves quite a good impact on learning. So please read whatever concepts we have covered today and come up with the concerns, queries and doubts tomorrow if you have any. Then we will continue in our tomorrow's class. Bye, good day.